Hello everyone. Earlier this year I recorded a series on Autodesk Subassembly Composer. The most common feedback I received after that was, could you please record some videos relative to retaining wall creation? So today I'm finally able to do that. This will be part one. Part one, we're just going to talk about some basics, go through some tips and tricks for creating any type of structure, a retaining wall in this case. So here I am, I'm in an empty subassembly. First thing I'm going to do is go to my target parameters. I'm going to create a existing ground surface target called EG. It's kind of a standard that I always do. And then I'm going to flip to the input and output parameter tab. So the focus today is going to be on the creation of the geometry. So now let's drag a point in. This will be the location of my profile where this will attach to. And when you're drawing a structure or a retaining wall, something like that, we kind of have to decide which direction you want to start. Sometimes this is a trial and error process. So many times what ends up happening is you start one way, you can't go any further because you don't know a particular value, so you have to go the other way to complete the part. And that's really what I want to show today. So now I'm going to place a second point, and we're going to assume this is the thickness. This will define the thickness or the top of the wall. So I've got P2 going from P1. But for my delta X, I want it to be an input parameter. I want to be able to control the thickness of this wall. So I'm going to create a parameter, and I'm going to call it thick or thickness. And remember, for the display name, I can change that if I wanted a simpler display name in Civil 3D. And for my default value, let's say that the default thickness is 1. And now back on my delta X, I want this to just be thickness. So I'll fit the screen, and here's the top of my wall. And now I have an input parameter that I can control that to change the geometry. Well, let's continue. Now we'll go down the wall. So imagine a shape with a simple wall with a footer at the bottom. So it's an L-shaped structure. So I'm going to go down the wall. I'm going to place a point. This point will define the height of the wall. So again, I need another input parameter. So notice how I'm doing these parameters as I go. That's okay. Sometimes you don't know everything before you get started. So for the delta X is 0 because it's going to be an infinite slope on the wall face. For delta Y, however, I want to set a minus height. So go down or minus whatever value I can for a height. And let's put the default height to 8 feet maybe, and we'll fit the screen. So here we are coming down the wall. We're ready to come out this way for the footer. The problem is, in the dimensions that I have, I don't really know that distance. I know the width of the footer, but the width comes all the way back to here. Now I could probably do this math. You'll see in this particular case, we could still do it. But as I mentioned before, many times you'll get in a situation where I'm not able to define the next piece of geometry, and I have to come back to the starting point and go the other way. And really, it would be easier to do that in this case, instead of trying to compute the value of the width of the footer from here. So I'm going to place another point, but now instead of the default, it's relative to 0.3. I'm going to change that to 0.1. And now I want to come all the way down to the bottom of the footer. Well, that's the height of the wall plus the thickness of the footer, or the spread it's called. So we need a parameter for spread, or the thickness of the footer. So I'm going to type in spread, and we'll set the default here to 1.5. That is a value for our spread. So what we need for this point is to come down the distance of the height and then add the spread. So let's do that for the delta Y. So we're going to say I want to go minus height plus spread. So I want to add take the height value plus the spread value, add them together, and then go down, which is the negative, in this direction. We'll fit the screen. And now we've located the bottom corner. Because we know the width of the wall, now we can place the point here on the bottom of the wall footer. And so that is just called a simple width of the footer. So we'll just key in another parameter and go ahead and call that width. And the default width will be 6.5. Place another point. And delta Y is going to be 0. Delta X, however, will just be width. You can see that placed. So now we're ready to define the top of the footer of the wall. There are a lot of different ways to compute this point. Me personally, what I like to do is if I have points defined already by input parameters, I like to use the geometry of the points to place that point. In other words, I don't like to add another input parameter value for this. I would like, since this point 3 and 4 are already driven by input parameters, if I can locate this point at the top of the footer relative to something that's already been defined, that's the way I would prefer to do it. A lot of different other ways, however. You could even do an intersection. We have intersections here where I can intersect this direction and this direction. But this actually used the location of P3 and P4. Just to remind, let's go back up to P3. It is defined by the height of the wall, so it's going to change based on that input parameter. P4 is defined by the height of the wall plus the spread, so they're totally defined by input parameters. So let's drag a point in. And what I can do here, x is 0, we know that. So for delta y, what I would like to do is take the y location of P4 and subtract out P3. To do that, we'll do P4.y minus P3.y. Now these expressions are in the help file if you need to be reminded on what is the proper way to input the location or the y location of these points. I'm going to fit to screen. Notice the distance looks correct, however, it's going the wrong direction. Because I subtract out a value coming down, I need to make it positive by setting a negative in front. So we'll say minus, open parentheses, fit to screen. So now P6 is going to be driven by P3 and P4's locations, which are being driven by these input parameters. So now we just need a link connecting the dots. So this will go from P3 to P6. That'll close that up. We've got a link there. And then last but not least, we'll draw in a shape code. I can add the links here. I can just click the shape in the middle and it will define the links for me. So let's do some testing with the input parameters. Let's check a thickness. We'll change that to 2. Notice P3 went with it. It should have. That's great. We'll change that back to 1. Let's try the width of the footer. We'll change that to 4. And let's go the other way, 8. That looks good. And then last, we'll try the height of the wall. We'll go to 12. Fit the screen. So this seems to be performing well. Now the last thing that I did not add is we're going to add our back slope. So let's say we know a location here. And again, doesn't really matter what it is, but let's just say we have a standard value. We want to come up from P4, and that will be our surface catch slope. So we need a point. We're going to drag that here, and we're going to leave from P4. From is going to be P4. Delta x is 0. Delta y, we could call this cover maybe. And remember, I don't have that as an input parameter. See, I'm doing these as I go. So I go back to one more input parameter, call it cover. And we'll set the default to maybe a foot. And now for delta y, I'll say cover. So now P7 is driven by input parameter. But let's make sure if P4 moves, we need to make sure that moves. Well, it should, right? Because P4 is driven by input parameter. This is driven directly by P4 and another value. Well, let's just check it. Let's change my height back to 8. Fit the screen, and that looks good. So last but not least, we're going to add in our surface link and point. So one more point, and we're going to leave from P7. That's great. And we're going to do a slope to surface. Again, the slope could be an input parameter as well, let's say, but in this case we're not. We'll just do a minus 33%. We'll just do a fixed slope. Notice we don't see anything yet, so let's move our existing ground surface below. Notice it is the wrong direction, so we're going to reverse slope direction. So now as our EG moves, you can see the catch slope working. So the goal for part 1 was just to show an intro and some tips and tricks into retaining wall design. The same really applies for any more advanced closed structure. I hope this has been beneficial. Have a great day.